All right, let's go ahead and get started on linear inequalities, which is the last section of chapter 4. So an inequality is a relationship comparing two quantities that may or may not be equal. So remember, we use the less than and greater than signs to show that. When you multiplying or dividing both sides by a negative number, remember, we have to flip this sign. So let's do solving an inequality like we did in chapter 2. Remember, we would have to isolate the x alone. But there came a point where we often had to divide by a negative, and that resulted in flipping the sign, the inequality sign. So, and when we graph this, we put that at -2, and then we said that x is less than that, so it better be on the left side of it. Okay. So how do we build on this? Well, we had equations with one variable, and now we're going to work with inequalities with two variables. All right. So how does this look on just the basic level, of what I want you to be able to do? Is you're first going to graph, or at least like a very light sketch of the line. So the line that's involved here is y equals 2x minus 1. So I want to take a really faint color here and write down and do the slope thing. You're just going to plot the line like we always do. So go to -1, go up 2 over 1, up 2 over 1, and we continue doing that, and we get a line like this. Okay? Now, after you do that, in order to address the sign, you have to ask two questions. Dotted, let's get my color back. Dotted or solid? Shade above or below? So, and we're going to show this in a second in this box that's under here. But this is not an or equal to. So our solution is going to have a dotted line. So now we can ignore that light gray. And because it's greater than, we're going to shade above. So I just do these long lines as shading. But guys, what this shading means is that points that are inside that shaded region, like -3, 3, it is a solution of the inequality. If you plug in -3 into here, and you plug in 3 into here, from this point, -3, 3, you will get a true statement. 3 is greater than -7. Okay? So all of those points, the collection of all of those points under the shade, those are parts of the answer. So in contrast to these inequalities, where it was like, oh, just this collection of numbers, now we're looking at a whole two-dimensional grid of numbers that we shade in. And they're all points. Okay? So let's just hop to this one real quick. So remember, we want to isolate y. So we got to divide, in this case, by a negative. So I flip that sign. And remember, I take the -3 and I divide each of the things by -3. Okay? So let's do the light gray thing again. Let's plot the point down there. And I'm going to do the slope. So remember, slope is 1/3. And b is -3. So go down to -3 and then go up 1 and over 3. Up 1 over 3. And then we can go down 1, left 3. So go the other way too, if you want. But that's the line, right? So in in that section, you'd be done. But now we're doing inequality, so we have to shade. So remember, it's two questions. Do you dot it, or do you make it a solid line, or do you shade above and below? Yeah, so there's two questions there. So this is a or equal to. So we do make a solid line. And because it's less than, we shade below. Okay, that's it. That's everything. So let's summarize with this box here. So when you don't have the line underneath, we're going to use dotted lines. And when you do have the line underneath, it's going to be solid lines. So this also kind of corresponds with the filled in dot and the open dot, and with the parentheses and the brackets. So it's not a new thing. It's all kind of means the same. Now, if you have a less than sign, you're going to shade below the line. And if you have a greater than sign, you're going to shade above. All right. So, and you must solve the inequality for y first, if you want to use these rules that we're dealing with here. Okay. So let's do 2 more practice problems, and then we'll kind of flip the script and look at it in a different way. And we'll do like a short word problem. Y is not by itself. So I got to move that 5 over by subtracting it from both sides. And then I want to divide by a negative, which means I need to flip that sign. So I change this, the positive negative sign for everyone, and the inequality sign has to change too. Okay. So I see the slope is -1 and the b is 5. So I'm going to take my lightly shaded pencil and mark this line. So it's got a negative slope. So it's going to go down 1 over 1. And I want to get something like that. Okay? And then your 2 questions. Is it dotted or is it not shaded? Is it dotted or is it solid? And the beginning of the problem tells us that it's going to be solid because it has that or equal to sign. So notice here that we have, these are both solid. Okay. Okay, and now do I shade above or below? So for that, you're going to look at your solved equation. After all the flipping and moving and everything, we're going to look at that sign. And is that a greater than or a less than sign? It's a greater than sign. Remember, the less than sign kind of looks like an L. So that's how it's like if it's a sideways L, like you could like rotate it and make an L. But with the greater than sign, you can't do that. So anyhow, we have to shade above. So this would be a good graph. Again, so if you saw this picture and you're just like asked, hey, interpret this, you would say that it's graphing the collection of all these points that satisfy the inequality. Okay, so like 5, 5, for example, does work. If you put a 5 here and a 5 here, it is a true statement, believe me. Okay? All right. What about this one? We got a fraction going on, but we still want to isolate for y. So I'm going to move the 2x over, and I'm going to go ahead and multiply by 2 to both sides. Distribute that 2 in. And there we have it. Not so bad. So, things to note. The slope is -4 over 1. B is -6. So, if I want to do my light line, I'm going to go down 4, which is a little problematic, and over 1. So I want to plot the other point too. So remember that you could also write this as let's fix this there. You can also write these fractions the other way. So this could be a go up 4, 1, 2, 3, 4, and go left 1. So we actually have 3 points now on our graph. So, but remember, I don't always move to the right, but you can also backtrack with the slope. But I'm going to try and avoid having questions on an exam that you have to go off the grid super far. Anyways, now, okay, do I shade it or do I dot it? Shade it or dot it? Well, this is not a or equal to, so I'm going to, I'm going to dot this one. Okay. So that is a dotted one. So we see, we use dotted when we have no or equal to bar hanging around there. Okay, and then where do I shade? Do I shade above the line or do I shade below the line? And because it's less than, I'm going to shade below. So, and if you're confused, like sometimes like for this one, it's kind of confusing maybe what's above and what's below. You can always look here at the y-intercept and ask, okay, I want to shade below. So it should be all of this. Sometimes looking at a particular point can help you. Anyhow, that's that. Okay? So questions like very well, this could be on the test. Just these 2 questions changed up a bit. Okay? Now, we can also, and maybe one of these as well, we can also write the inequality based on the graph. So every one of these is going to be y equals mx plus b, but remember it's going to be an inequality sign. And if it's dotted, the choices are less than or greater than. And if it's shaded below, that narrows it down. It's got to be this one. Less than means below. So the slope, we have to count the slope, right? Down 1, over 1. So the slope is -1. The y-intercept is -2. So it looks like the answer is just this. So it's just like finding the equation of a line, same thing, but then you have those 2 things you got to worry about. Is it less than, greater than, and does it have an or equal to? Or in other words, where is it shaded, and is it a dotted or a solid line? So let's practice that again. That wasn't very smooth. Let's try that one more time. So this is -1, and we need to find the slope of this. So I want to pick 2 nice points, go up 2 over 3. So the slope is 2 over 3, and the y-intercept is -1. So I can set up basically the whole answer, but I don't know which 4 of the signs this is. So you ask the questions, are you dotted or solid? And this is a solid one. So our 2 choices are this or this. And then are we shaded above or below the red line? We're shaded above. So that makes this a greater than, so that we get the answer there. Okay, see how this works a little bit? It's not a bunch new. This one, it's a real fast one if you know what's up, because this is at 2. And it's a 0 slope line. It's horizontal. And those are y equals lines. So this is y equals 2 is the line. Now, the inequality, though, I have to pick a sign. Is it above or below? Is it dotted, solid? And that sort of thing. Well, this one is dotted and below. So knowing it's dotted means it's one of these two. But below is going to be a less than idea. So that's the inequality for this graph. So it's actually kind of interesting, like that inequality, when I look at that, I think of a number line, like 1, 2, and going like this. So it's a little interesting, right? They kind of mean the same thing. But this one is just set up for a bigger space, and it's set up for points. Anyhow. So a little bit of a challenge problem to wrap us up here. Let's say you're going to this amusement park and it's got small rides and large rides and they cost a different amount of tickets and you only have $15. The question is, how many small and large rides can you ride? And that's a very open question, and we'll see why in a second. But so let's imagine we're going to this amusement park and we have $15. I'm going to cash all of that out for tickets so I can go ride these rides, right? So if you have $15 and each ticket is 25 cents, how many tickets do you get? Right? Kind of asking like how many quarters can you make out of $15? Yeah? And let me just tell you this, if you have $1, that's 4 quarters, right? So if you have $15, multiply this by 15, we should multiply this by 15. So I'm thinking we're going to get 60 tickets out of this. So I'm just going to start there, right? Now, if we want to make an equation for this, we have, so say you rode like 7 small rides. That would be 3 tickets times the 7 rides that you make, right? So there's this multiplying that's happening. So we'll call that x. So x is going to be the number of small rides ridden, and we're going to call y the number of large rides ridden. So we need to come up with some sort of equation, and in this case it's actually going to be an inequality. I'll show you why. Involving this x and y, and this 3 and this $5, or 5 tickets. Turns out the equation is, you got 3x plus 5y, right? 3 tickets per small ride makes 3x. And then 5 tickets for every large ride is 5y. And then the biggest that can be is 60, because you only have 60 tickets. I mean, you can go to the amusement park and only spend 20 tickets and walk home with your extra 40 if you really want to. So that's why the sign on this is going to be less than or equal to. Okay? And just like that, we can draw a decent picture. We might want to solve this. I'm going to solve this for y first real quick. There's a number of ways to do this too. And it's more of a challenge problem. I don't really expect putting this on a test, but it's kind of a neat thing to think about. So we're going to go up to 12, and then we're going to go down 3 over 5. Down 3 over 5. So something like this. I think this is going to go to 20. There we go. I made it solid because it is or equal to. I can spend exactly 60 tickets, and it is less than. So we're going to shade below. But remember, we can't go on a negative amount of rides. So with a lot of these real world problems, we're going to restrict ourselves to the first quadrant. So it's actually just this shaded part, which is our answer. So the graph is the solution. It's basically saying if you want to go there and ride 5 big ones and 5 small ones, that's fine. You have enough tickets to do that. You're in the blue zone. You're safe. But if you went and said, I'm going to ride 20 small ones and 15 large ones, you can't afford that, right? So that's why this is the solution. The blue is saying this is what you can ride. Any point that you pick in here or on the line is safe. So kind of an interesting question there. I like those problems. All right, that's it. I hope that wasn't too much, but that's it.